Sorry, wait. What is wrong now? Share screen. Oh, why is that? Wait. Correct. No, it doesn't. Why doesn't it show? Not better. There's a lag. Okay. Very good afternoon to everyone. I hope you are doing good during this MCO period and still keeping healthy, either at your home or at your workplace. So once again, welcome to our Ebara Pump webinar series. And thank you to every one of you who have allocated your time to tune in for our third installment of our MCO 2.0 webinar on the theme of achieving efficient and quality pumping systems within building services and commercial construction projects. And also a big thank you for those who have followed us during our 2 webinars over the last few weeks. And we hope that these sessions have been beneficial for you to not only gain some understanding about pumps, but also on how it can help you to select and design the right equipment and system for your application. A little introduction to myself for those who have just joined us for the first time. My name is Eddie Lee and I am the Business Development Manager for Ebara Pumps Malaysia. And I guess most of you are already familiar with our company Ebara Pumps. And for those who are joining us for the first time, you have been introduced to our company video and the nature of business just before this, just before we began. So I will not go through our company details again. And with me today is my co-host, Miss T, who will be my assistant for this webinar. And one of her main tasks will be to consolidate all your questions at the end of this session so that we can answer them. So if you have any questions, please type it into the chat column. And at the end of this session, we will consolidate it and go through and answer as many as we can. Now, our topic for today is entitled Good Pump Installation Practices and Noise Control Solutions in Buildings. Now, most of you are from the consulting line and as well as project engineers, and many are also involved in the construction industry or even facility engineering. So you deal a lot with pumps in your line of work, whether it is selecting, designing, purchasing, installing, or even maintenance of the pumps. Now, you may have the best plumbing or pump system in the world, but if your pumps are not installed properly, not only will it not give you the performance you need for your system, but also give a lot of maintenance issues later. So this topic will cover some fundamentals on how pumps are to be installed properly to ensure it will give you the best performance for what it was designed for, and also ensure that it will run well and provide long lifetime with minimal maintenance issues. And at the same time, on the subject of installation, we will also take the opportunity to cover a very interesting yet unexplored topic, which is on noise control solutions for pumps. Now, as you know, as in today's construction, it gets more and more dense. You know, developers are trying to pack as many residential or apartment units as they can in a development. Or even if you are designing for a high-grade commercial building like a high-rise office or shopping center, or even government facilities like hospitals and government offices, there is a need for a good system with high design standard that emits very little operational noise for the comfort of its occupants. So this topic will cover a little bit about the subject of pump noise. And yes, as part of this webinar, we will also have some quiz questions for you to answer. So we will give out prizes to those who can answer fast enough, yeah? So all you have to do is answer the quiz question in the chat column on your Zoom interface, and whoever is the first or the one to get the right answer will win a nice prize from us. So how do we do that? Well, basically, if you have been declared or announced the winner for that quiz question, so you just send us an email with your name and address details, and we will courier you the gift. Okay, so all good. So congratulations to those who have won some of the prizes that we sent out over our last 2 webinars. Okay, so once again, in case if you have any questions related to pumps or our products or company or anything that you wish to know about Ebara, just type it into the chat column on your Zoom interface, and we will then consolidate all the questions and have a Q&A session at the end of the presentation. Okay, so we will try to handle as many questions as we can. So just fire away with the questions that you need to be answered. So before we begin, let's start with the first quiz of the day. Okay, so pay attention, everyone. So first question is, what do you think are the elements of a good pump installation? Now, can you at least put 2 elements? Yeah, I can hear some voices. Thank you. But you need to type it into the chat column. Okay? Give me 2 elements at least that you know that makes a good pump installation. Yes. So, okay, we can see some answers there. Copper, waterproofing, alignment. Very good. You are thinking fast and hard. Alignment, vibrations, and alignment. Okay. Anyone else? 2 elements. Alignment, yes, is one of them. What's the other one? Head capacity, water level. Okay. What are the 2 that we got? I saw one answer just now. Efficiency and low noise. Efficiency and low noise is not really the elements of a pump installation, but no, something about alignment and vibration isolator. Okay, alignment. Okay, we will give the answer to that person who answered alignment and vibration isolator. Who is that? MEDSYS. Is that a company name? Oh, okay. MEDSYS. Okay, so Mr. MEDSYS, you won that prize. But we want to expound on what you have answered. So thank you for that. Now you can see an example, or rather a clue here as to what makes a pump installation. So now let's go to the topic. Now, when it comes to the correct installation for a pump system, there are 3 important points to take note. Okay, the first is what we call the pump foundation. And this is basically the support for the pumps that you are installing. Secondly is the piping arrangement and how the pumps are connected to the pipes, both suction and discharge. And this is also important in the whole pump installation scenario to ensure your pumps will run well. And thirdly, as what you answered, pump alignment. And that basically means how the pump connects to the motor. So these 3 factors, when done correctly, will allow your pumps to have the best conditions for its performance and ensures that it will perform at its peak efficiency. Okay, now you can see here that in a nutshell, correct and proper pump installation practices can mean the difference between a pump that gives many years of trouble-free operation or one that requires what? Yes, constant and repetitive maintenance. So you end up keep having to maintain or keep having to service the pumps very frequently because of poor installation. Now let's go a bit deeper. Let's start with the pump foundation. Now this is an example of one of our installations in one of the water treatment plant in Nvh. So there's a simple saying, a good house must be built on a strong foundation. So this is the same for a pump, and even more because the pump generates dynamic outward forces in its operation. Therefore, it is important that the pump must be well supported. Now, let's look at what happens when a pump is running. When a pump operates, due to the centrifugal action of the pump, there are many forces and thrusts at play in the pump. Now, the pump is subjected, let me just point here, to its centrifugal forces when the impeller is turning. And at the same time, the liquid action generates both radial and axial thrust from the pump. And all these forces and thrust has to be taken up somewhere. Now, in our last two webinars, we talked about Newton's laws of motion. And basically, as long as there is an action, there is a reaction. So this is where the reaction of the forces from the pumps come into play. Whenever there is a centrifugal force acting, there will always be a reaction acting towards the motor, which is the axial thrust, as well as the radial thrust. Therefore, the function of a pump foundation is to absorb these forces, and not just the forces, but the torque and the vibration generated by the pump operation, so that it is not transmitted to the pipings and the floor structure. Now, horizontal pumps such as end suctions or split case or horizontal multi-stage types of pump should be mounted on a strong steel base plate supported by strong concrete foundation, like what you see in some of the pictures here. Now, the steel base plate is like the feet of the pump and the motor assembly. It has to be designed to take up not only the weight of the pump, but also allow the whole assembly to be carried or transported around. Now, you may ask, can the steel base frames support the pumps without the need for a concrete plinth? Because I'm sure you have come across some installations where there was no concrete foundation and the pump is just mounted directly to the floor. Now, if the pump is a light pump, such as a small, for example, small closed couple pump or a small vertical multi-stage pump, then I would say that the pump can be mounted directly to the floor. However, for horizontal style pumps, a good foundation is required to absorb these dynamic forces as well as ensure that vibrations are not transmitted to the floor structure. So the rule of thumb is that the concrete foundation must be around 5 times of the combined weight of the pump and motor to effectively absorb the dynamic forces. So this can be calculated easily by assuming a concrete density for the plinth of around 2,400 kg per cubic meter. And from there, you can determine the size and the height of the foundation easily with this method. And not forgetting, at the same time, Always design for ample working area around the sides of the pump and lifting tool facility also, such as a chain hoist and even cranes for larger pumps for future maintenance works. So you can see from the pictures there in the slides, some of the good installations in some of the projects that we have supplied, and I would say this is very commendable. Now, another important consideration, especially for pumps that are inside a building, is the isolation of vibrations, which can affect the surrounding areas and in worst cases, transmit it through the pipings. So these vibrations can create cracks within the wall and floor if it's too much, and also create leaks in the piping system over a long time. Therefore, inertia bases and spring isolators like what you see here in the picture can be used to counter these effects. And in some locations where there could be seismic movements, seismic movement meaning a little, I wouldn't say earthquake, but in places where there are bound to be some seismic activity. For example, if you are designing for a high building in Kota Kinabalu, Kota Kinabalu had some cases of a minor earthquake there before. So these isolators will definitely be required. And also flexible or expansion joints are also a good method to isolate some minor vibrations from the pipe as well as compensate for thermal differences. And there are quite a lot of types of these, so it is also recommended to be applied to your piping system. So now, inertia bases and isolator springs have to be sized against the weight of the pump. And this is a very specialized calculation, so there are specialized suppliers for this type of products. So we will not cover this in detail here. So the next quiz, now this is to enhance your understanding. Now you see from the picture here of a pump or facility that is still under construction. Now, what should be the theoretical load mass for the concrete foundation plinth of a pump and motor that weighs around 1,000 kg or 1 ton? Anyone have any good answers? Yes, very fast. Thank you. Who got the first answer? 5,000 kg? Muhammad Ezwan. Okay, thank you, Muhammad Ezwan, for listening. You got the answer right. So it should be around 5 times the weight of the pump and motor. And if you were to calculate what would be the size of the plinth, then basically you just need to divide by 2,400 and you get about 2.1 cubic meters. Yeah, so with the height and the length, then you can determine what would be the width and the length. You can determine the height of the plinth. Now, this is just a very rule of thumb calculation. There are a few other factors, but generally you can assume that with this method, you can get the plinth size. So thank you, Muhammad Ezwan. Yeah, okay. So that's the answer to quiz number 2. Now, next is what we call good piping arrangement. So we have covered good foundation. Now we talk about good piping arrangement. So what do we mean by this? Basically, how the pipings are connected to the pump will affect how the pump performs. So at the suction side, the pump needs to have a good intake of the fluid so that it can have the capacity to produce the flow and the head required. And at the discharge, there should be no restrictions or any form of obstructions which can cause a large pressure loss or even back pressure acting back on the pump. Now, sounds simple, right? But this is where a lot of things go wrong. So let's look at this in more detail. Now, what do we mean by maintaining an optimal pump suction condition?
Hello.
Okay. Can everyone hear? Okay, host is back. Yes, thank you. Yeah, I think there's a bit of problems here. Maybe we have our competitor is hacking into us, but nevertheless, our apologies. There was a bit of a problem with our line. And let me try to get back to our presentation. Okay, there's a bit of lag here. Okay, so I think we are back online, yeah? So let's come back to here. So maintain optimal pump suction condition. So at the suction side, the most important point is to ensure good or optimal pump suction condition. Now, in pump terms, we call it good MPSH. Okay, so MPSH means net positive suction head. So basically, it is a measure of the suction ability of your pump. But MPSH has two forms. One is what you call MPSH available. And MPSH available is basically the MPSH value that the current installation of your pump will give to the pump. But at the same time, every pump has its own MPSH required. So this you can actually check from the pump curve. So basically, MPSH required is the MPSH value of what the pump needs in order to take suction effectively. So with this understanding, basically it means that the available MPSH in your installation or your pump system, that means in your piping, and that means your water level and whether it's positive or negative and your pipe length and so on, will affect the MPSH available given to the pump. So the available value has to be more than the required value in order for the pump to take suction effectively. So apart from that, the next is also to reduce both friction and vortex formation at the pump suction. Now you can see from here that one of the common problems is when you have an elbow just at the suction of the pump and a very sharp or small radius elbow. What can happen is that there will be a lot of turbulence that can happen before the suction of the pump, and that will reduce the MPSH available into the pump and cause some, not just poor suction condition, but even cavitation. And if you have a very long pipe from your tank to the pump, then it has very high friction losses and your pipe is small. And that is also another condition that can cause poor suction. And not only that, air locks. It's important to eliminate air formation in pipes. And basically, you can see here that one of the problems that people don't realize is that if you have a U bend before the pump, then it creates an airlock issue. So it's very important that a centrifugal pump must be primed fully to ensure that the pump takes suction all the time. Now, let's go to the piping connections. So after foundation and after the piping, now we talk about these piping connections. So pipe diameter should be at least equal or one size larger than the pump inlet. Okay, it can never be smaller, because when the pipes are smaller than the pump inlet, that is where the pump will face suction issues. The pump is inlet and outlet have all been designed by pump engineers to have a certain flow into the pump. So you should never compromise on that. So in short, pipe diameter should be equal or one size larger to allow for ample water supply. And also ensure that the pump is not strained by the pipes and not supporting the pipe weight itself. You can see in many cases when the pipes are installed or connected to the pump, instead of having a free force here, the pump is actually, or rather the pipe is straining to hold against the pump or vice versa, and that creates a lot of pipe strain. So all pipes must be supported by pedestals or even pipe hangers if they are running below the ceiling, and not to let the pump take the weight of the pipe. Then the next is also on reducers. Now, in a lot of supply systems or plumbing systems, reducers are used. So it's important that when you use such reducers, there are both eccentric and concentric reducers, and there is a right way and a wrong way to use them. So you can see from this installation here how the correct way of using both an eccentric reducer and a concentric reducer. So in this case, an eccentric reducer, the slope must be at the bottom part, not at the top. Because what can happen is that if you put the slope on top, then there will be, even if you use such a, what we call a concentric reducer, then there will be a risk of air formation in the pipe, which can affect the suction of the pump. And in another case, if your pipes are coming from below, then the slope should be below. But if your pipes are coming from the top, and you can see here with a very big radius elbow, then technically the slope part of the reducer should be on top. So this is just some of the theoretical or good design practices of using both eccentric and concentric reducers. So that's on piping arrangements, some of the pointers. Now we go to the next topic, which is on good pump alignment. Now you mentioned about pump alignment just now, and this is also very important because all rotating equipment needs to be balanced as well as aligned to the motor correctly, and not just aligned both radially but also axially to ensure that it rotates smoothly at high speed. So this is the same like your car. Yeah. So if your car wheels are not aligned properly, then you can imagine that you will always have a little bit of vibration in your car when you are running along the highway, and that the road holding will not be good, and you may not even be going straight if you let go of your steering wheel. So that's a sign of not good alignment. So you can see from here that some of the alignment pictures here, just to give you an understanding. Now, correct shaft alignment from here ensures smooth, efficient, and right transmission of power from motor to pump. But a misaligned or badly aligned pump and motor will result in three things. Number one, vibration, which leads to noisy operation and causing pipe strains. And in worst case, bearing and internal parts damage. So it's very clear. So in short, to avoid this, both motor and pump should be aligned properly and periodically in all your installations.
Yep.
Now, there's a few types of alignments from what you can see from the picture here. There's a horizontal alignment where the alignment of shafts is in the horizontal plane. And there's also a vertical alignment or misalignment from this picture where the shaft of the motor and the pump is misaligned and it shifts from each other. And this is usually caused by a difference in the height of the pump and the motor. And angular misalignment. Angular misalignment, you can see from here what happens is that it could be the pump or it could be the motor is tilted from one another, and from there then also misalignment happens. So the question is, when do we know when the pump needs to be aligned? So as mentioned before, what are the symptoms that you can see or can feel? So let's just see a short educational video on this. And this is courtesy from a specialist company that deals with pump alignment. Okay.
Yeah, that's what I thought, but I don't think we have lah. You double check one, then you let me know, because this is for one of the in the clarification list that you sent to me. Your plan.
Wait,
don't have, I take it off.
FAT even for pumps also don't have ma. We got. No.
You double check.
Even our aircon pump also don't have what? Oh.
That's what I thought.
So I think don't waste time with that. We go ahead with Temper first.
They're free now.
Now go sound?
Yeah, they're free. We join the Mountain Temper.
I give this guy one last.
Just a short video. Apologies again. There was a bit of problem with the sound, but I hope you finally got the sound on your screen. So let's go to the next quiz now, and this should be quite obvious. So prepare your keyboards. So the question is, what are the symptoms of bad alignment on a horizontal type pump, like for example an end suction pump?
Are they allow us to put two brands?
Yes, I saw. Good. Okay, I saw many good answers. So that means you all have been listening. So I want two answers, and I think I saw two: vibration and noise. Okay, who got the first one? Yeah.
For the crack meaning, right?
Muhammad Alif. Okay, so correct. So actually, okay, someone Afiq, vibration, noisy operation, and pipe strain. Thank you. In fact, you answered more, but we wanted someone who answered fast enough. Never mind, you'll get your chance again. So the correct answer is more vibration and more noise, yeah? Not just vibration and noise. But nevertheless, congratulations. So the answer, vibration, noisy operation, and pipe strain. And in worst cases, failure of pump and even motor bearings. Yeah, I mean, in a very short period of time. So on that tree, we have covered what we call the essentials of a good pump installation. Now let's go to the next subject matter which we talk about, and this is regarding pumping system noise control solutions. Now, before we go into this, let me just take a quick survey. How many of you all have come across this problem? Type yes in the chat column. That means either your client, maybe the building owner or developer or even the residents itself complains about the excessive noise from the pumps, because either their unit is near to the pump room or maybe they have very sensitive ears, and even if they live further up, they can hear the sound. And sometimes it may not even be the sound of the pumps, but actually from the pipes. So you could hear like chattering or water noise or even water hammer. So type yes if you have had this problem before. Okay, naturally pumps are loud. Well, yes and no, but thank you for that comment. Are there a lot of yes? A lot. Okay, good. So how was the problem resolved? Can someone share, those who have had this problem? What happened, or what did you all do to solve the problem? Or was there a solution at all? Anyone? Inertia block. Okay, very good. Anyone else? Install acoustic insulation. Yes.
And yeah, one more thing is.
And any more? Inertia block and acoustic insulation. Are there any other method? Isolation springs. Okay, so let me ask you, did that solve the problem? Did it reduce the noise after doing that? Not solve. Okay, so how? Ask my boss how to solve. Yeah, the boss said that's why we hired you to solve the problem. The NC only. Okay, so thank you for your comment. Uninstall pump, so don't use pump. That's the best solution. Yeah. Okay, so now before we go into this subject, let's understand a little bit about sound levels. Okay, now this is very important because it gives you a full understanding of how to treat sound. And you know, there are even sound and audio engineers that spend their life just learning and doing this as part of their work. So the unit for sound measurement is decibels. Okay, and because sound is a waveform, it is measured both in sound intensity and sound pressure. So now, due to time constraints and not to put you to sleep on this nice Friday afternoon, we cannot go too deep about how sound is measured and what are the different technicalities about measuring sound and so on. But here we would just like to give you an idea of what is the relative measurement of sound from our surroundings, so that you know where is the benchmark or base level. Now, to specify the loudness of a sound in decibels, or dB in short, our standard reference level is the human threshold of hearing in a healthy young adult. Yeah, not a 90-year-old man or woman. Yeah, because usually in that, when you are that old, usually your hearing is impaired a little bit. So healthy young adult. So if we take a healthy young adult, then the sound value of 0 decibels or dB is the softest sound a person can hear with normal hearing. Okay, there is no negative dB because it starts with 0. Now, if you are in a regular office, yeah, in your office, then the sound level would be in the region of about 65 to 70 dB. Yeah, and you can see from here some of the examples of what is the dB value of different sound, like whether you're breathing or whispering at 5 feet and so on.
I think for the most
now,
you replied with
if you just want to have an idea about your sound, that one, you can easily install, you know, if you have, I mean, I'm sure you have Android or Apple, you can just look for what we call sound meter apps. and
so
you
we
can
just go
install,
through
and
quickly.
straight away your phone
G1
can
item
become a
1,
sound meter.
just for your info, you also need to apply
And
to
you
this
can just do that, yeah.
contract to
So
follow
now to specify the loudness of a sound
for your standard price.
okay, so I
Inclusive
mentioned
of
here
SST,
already.
yeah.
So now you
Really
can
to
see
the
here on the different levels of the
There's one common
decibel value
maintenance,
of
Yeah, okay.
different
Maintenance on your
scenarios,
previous
whether you are at
like
home
general
or at
maintenance
work,
only.
yeah. And
You want to
from
maintain
here,
it,
whether
you have to include it
you
in
are
the
using
price.
a washing machine or air conditioner and
It's
so
comprehensive
on.
maintenance, you know.
And even here, I put here, if you are in a home and you have a, sorry to the women, but for
Yes,
men,
full
if you have a
DLP
nagging wife, then the sound level could be 80 dB,
Okay,
yeah,
under
from her
supervision,
voice.
you put here
And if you're in the
time,
office
you
and
need
if your
time,
boss is very angry
shortly
because
after work,
you
then
made a
we
very
need
big
to
mistake,
revision lah.
or
Don't give
unfortunately you
partial
screwed up
lah. You need
something,
it
then
full. So
it could be
everything that
90
you need
dB,
for the
yeah.
project to run, you tender
So
it.
you get the idea.
Okay.
Because the project
So,
range is running. We
Now,
are looking at
the next thing that you should
completion by
know
around
is
March
that
lah.
sound values follows a logarithmic
Yeah, so don't give
rather
hard
than
time
a
lah.
linear
Next
scale.
time, make sure
Okay,
the
that
project
means
is done
that
correctly.
basically 20 dB, for example, is not double of 10 dB, but many times more following the logarithmic scale. So I will not go too deep into this, but basically it means that it is not a linear value. Okay, so a sound measuring twice the level of another would actually be in practice be many times the intensity level of the others. So you can see here that if the decibel value is increased by 3 dB, basically the noise exposure has doubled and vice versa. So by research and of course you know OSHA guidelines, yeah, long or repeated exposure to sounds at or above 85 dBA can cause noise-induced hearing loss. So that is why there are strict guidelines on this, even from our Malaysian DOSH, Department of Occupational Safety and Health, about prolonged noise exposure in the workplace, especially if you work in a factory environment or manufacturing environment. And if you want to know more about this, you can always pick out their handbook on this matter, and it can tell you what are the guidelines and what are the regulations. But coming back to this, so let's go into the next quiz. Yeah. Now, next quiz is who or what was the unit decibel named after? This one I don't think you all will get it so fast. Anyone? dBA? No, Mr. Decibel. Okay. Yes. I got that, but you didn't get the full name, huh? I saw an answer there, but can you give me the full name? Alexander, that's not the full name also. There's a lot. Alexander Tan, Alexander Chong, Alexander. Yes. Okay. We have to give this to Muhammad Kamaru, Alexander the Great. Oh, sorry. I think you watched too many Netflix. Alexander Graham Bell. So, yes. Now, why or how was the bell named after Alexander Graham Bell? Now, Alexander Graham Bell, as you know, was okay, you may not know, but he was a Scottish-born inventor. And of course, his greatest work is the invention of something that all of us have today, yeah? And that is your phone. Yeah? Of course, he did not create the handphone, but he created the telephone.
Yeah, anything.
But once after he invented the telephone, engineers needed to be able, engineer, you can see from here that after that he formed AT&T, and of course AT&T is one of the biggest phone company in the world, at least in America in the heydays. I'm not sure about now, but once the telephone was created, engineers needed to be able to quantify these audio levels in telephone circuits. and also measure the transmission efficiency of
okay,
all the
Vincent,
telephone
one thing,
facilities. So they have to
this
create
contract, right,
measurement values.
You realize we put in the
So
watertight contract.
Bell Telephone Laboratories devised this sound measurement unit and name it, Bell, in honor of him, for Alexander Graham Bell, which actually invented the phone. Yeah, so that's just the story. So, but basically, the decibel is actually 1/10 of a bell to actually give it more value. Yeah. Now, let's go back to the subject of noise. So let's picture this. Now you go to a pump room and you hear a very high-pitched noise, or you could even hear it from outside. Or if you are unlucky, you bought a nice condo unit. Unfortunately, it is nearby to the pump room, and there is this constant high-pitched noise. Right? I don't know whether you face that. So where do you think the sound originates from?
I think based on
of course, you know it's from the pump room, but the question is from actually where, and because you want to treat it, right? So when it comes to noise identification in a building, there are two types of noise. Okay, so it is important to identify them clearly so that the correct remedy or solution can be taken. The first is what we call airborne noise. And basically airborne noise is the sound that travels or is transmitted through the air. But there is another type of sound which is the structure-borne noise. And this is usually the sound coming from the pumps or pipes that are mainly caused by vibrations transmitting to the wall or structure. So in short, the two main noise sources are always either the pipe or the pump. Now, why do I say pipe? Because usually you will also hear, especially if you live in a condo, or even if you go to a hotel, yeah, and you went to bed early and the person that is staying in the room beside you, he comes back late and he starts bathing and showering, and then you hear this shh. That's actually the sound of the water pipes or water flowing in the pipes. So that can irritate a lot of people also. So nevertheless, you can see from here, pipes also create sound, and that could be either from water flow or from vibrations. And vibration can be caused by either bands in the pipe, can be caused by water hammer or even pipe chatter. And from the pump, it will come from either the pump running noise, which is usually a humming noise, or a high frequency noise from the motor fans, or in some cases, pump vibration, which is transmitted through the structure. So we will try to address this in the next few slides, to go into a little bit more detail. So when we talk about airborne noise, what could be the problem? Now the sound is usually in this case very high pitched. It goes like that, yeah. So there are a few possibilities. If you hear a constant high pitched noise, then it is probably from worn out bearings from either the pump or the motor. But if it's not a high-pitched sound, then it's just the mechanical humming of the motor rotation. Now, sometimes you hear this very high-frequency sound if the pump is driven by a VSD. And that is basically sound that is generated from what we call over-harmonic frequencies, generated by these VSDs driving the booster pump or the pumps that are in use. And this is actually an electronic noise, and it doesn't happen to all VSDs, but to some VSDs where due to the switching frequency at the rectifier, it creates harmonics and some EMF interference. And where there are no harmonic filters inbuilt into the VSD, then this sound usually can appear. So in such a case, when you have either worn-out bearings or harmonic frequencies, you have to identify them, and there are mainly two solutions. Either you replace the worn-out bearings, and of course you have to ensure that the pumps and motors are maintained on schedule. Okay, so that's of course the key action that you need to do if the sound is the mechanical high-pitched sound. And if it's an electronic sound coming from the VSDs, then you add a harmonic filter into the VSD, or in some small VSD, you probably need to change the VSD to another brand, because not all VSDs are built with harmonic filters. So that is one of the case of what we call airborne noise.
Okay, then
now, next is what we call the structure-borne noise. And this is basically a low humming noise from either the pump or the motor, accompanied by a slight vibration when you feel the pump. And you can see from the picture here, this is quite obvious. It is mainly caused by the vibration from the pump set or the motor transmitted to the interior and the structure of the building. Either because the pump was installed without proper supporting or isolation structure, or like what we covered earlier, when it is not aligned well, so it creates the vibration, and subsequently the vibration actually caused not only the pumps but also the pipes to start vibrating.
You know about this, right?
So what's the solution for this? So it's also pretty obvious. Number one, of course, provide inertial blocks to support the pump set and spring isolators to absorb the vibration. So first, get rid of the vibration, because that creates, or rather is one of the source of the sound issue. And in addition to that, provide flexible connectors between the pump and also all the pipe work, so that this vibration is not transmitted to the pipes. And if you have pipes hanging below the ceiling, then also support it with spring hangers, and at the side, if you have pipes that run along the wall, then ensure that these pipes are securely mounted with proper pipe mountings. So all this helps to give good integrity to your pump system and reduce as much structure-borne noise as much as possible. Then you talk about sound barriers. So just now there was someone who said sound barriers. So in some cases, you may need to create a sound barrier if your pump room is situated very close to occupants or the residential units, especially for high-rise buildings with intermediate pumping floors. Yeah, today a lot of condos and high-rise apartments have intermediate pumping floors where you pump in 2 stages. So you need pumps at these intermediate floors. So that's where the pump room is. And sometimes it's also just below a space. So not just at the same floor, but also the floor above and below. And then you can hear the sound of the pump. Now, here are 2 examples of how sound or acoustic barriers can be constructed properly to get effective, let's say, effective solution to it. The first example is like what you see here, usually along some sections of the highway where a sound wall or barrier is constructed to prevent too much of the road noise to surrounding houses. So the sound barrier basically prevents sound from transmitting directly on line or sight. Now remember this word, line or sight, because it is important to understand that sound travels by line or sight. Yeah. So ideally, this type of sound barriers must be placed as close as possible to the noise source.
Next week.
And if you have a good sound barrier, then a reduction of a noise level between 5 to 10 dB can generally be resulted from using these barriers. So again, there are specialized manufacturers for this type of sound barriers. We are not the experts, so it's best to talk to some of these people who make sound absorption materials or even these specific sound barriers itself. Now, a much more effective solution is to fabricate a complete enclosure either around the pump or sound absorption materials on the pump room walls. And when you do that, then you need to have silencers at outlet and inlet because sound can still travel from the ventilation points. So you need to add in silencers so that all these are able to contain and absorb the noise energy that's radiated from either the pump or the motor. So an enclosure like this also requires proper ventilation to ensure minimal heat build-up. Yeah, and not only that, not forgetting the pump room door. It needs to be soundproof. So if you have such an arrangement or installation, then you can actually reduce the noise level effectively as much as 20 dB.
Okay, no problem.
Okay, now, in summary, when we talk about treating building noise, there is a very apt and effective saying which can be applied to this problem. And I'm sure you all know what the saying is. So prevention is better than what? Better than injection? Or anyone? Or sleeping already? Yes, so the word is cure, not vaccination. So prevention is better than cure. Now, what do we mean by this? Now, most of y'all, especially the men, you all have a nice car. So when you look at a car as an example, when we treat noise problems, it has to start from the very design itself. Yeah, and this has to be properly thought out during the design stage before all the equipment is installed and the pipes are laid. So if you look at, today's cars, everybody wants good or low NVH. Do you all know what is NVH? I think some car lovers, or if you read a lot of these car articles and all that, then you know what is NVH. Anyone? What does NVH stands for? No one. Okay, so NVH stands for noise, vibration, and harshness also. Okay, so when you buy a new car and if the car has very good or very low NVH, then you'll be very happy when driving the car because you can enjoy the good audio sound, and when you talk with your passengers in the car, you can hear them clearly because the car designer has designed the car well to minimize the NVH issue. So you can see some of the examples here, a lot of sound either absorption or eliminating features that creates or that what makes a good NVH in the car, all the carpets, all the boots, all the wheel wells and so on. So now, if you already has a car with poor NVH, and you want to improve it, so many of these car enthusiasts, they go to the audio shop and they add all kinds of sound absorbing materials, at the door panels and at the boot and so on. But after that, after paying maybe a few thousand ringgit to put all this in, you get very little improvement on this, what we call aftermarket products, because the materials can only absorb some of the sounds, some of the noise, but not prevent the cause of it. So in short, when we talk about treating noise, it begins right from the design process itself. which is four main things. Number one, equipment placement, selection of equipment, good maintenance, as well as right plumbing design. And if you do not have this, once the building is done and the noise issue starts appearing, then you can only look at some cure examples, such as the sound barriers or the absorption materials that we talked about, and even putting pump enclosure, or even you have to redesign the pipe and or even changing the pump. And of course, an expensive solution is to add inertial block and isolators. So that is why we say, I mean, if you look at it, all these cure cost a lot more, but result in not much gain. So in short, just to summarize, when we come to pumping systems, when you design and plan against noise problems, there are four major points of consideration that you should take note in your design. And one, of course, is what we call the equipment placement. Yeah. So a few pointers here. Number one, the equipment should be placed in a plant room with very thick walls. So you have to increase the size or the thickness of your pump room walls if you want to have good sound insulation or noise insulation, and put it as far away from occupants as much as possible. And if it's not possible, because of your architectural design or because of the location, then it has to be behind a large obstruction or barrier where there is no direct line of sight. Direct lines of sight meaning that it should not have a direct line to where your occupants are going to be. Very important.
Clarification number one.
Then, of course, the selection of equipment itself. So, of course, a quieter equipment may be more expensive than a standard equipment. I mean, for example, like silent running pumps. But in the long run, it is more economical to purchase a quieter equipment than to reduce the noise by modification or with noise control devices after the purchase. Oh, good. Thank you. Use Ebara. I see that. Yes, good. And we are going to just tell you a little bit more about some of our products for this. So you can see an example of an installation here using our silent pumps. Not only that, scheduled maintenance. Yeah, regular maintenance of pump bearings, greasing, lubrication, alignment, and of course, tightening or loose parts and so on. All these are part of ensuring that your installation will be running at its peak efficiency. Yeah. And not only that, especially for a lot of consulting engineers out there who design plumbing systems, correct pipe sizes, even the usage of variable speed drives to ensure flow control in all the pipes, and your pipe mountings and so on helps to reduce airborne and not just airborne, but also structure-borne noise from pipes and water flow. So we showed you some examples of how all these vibrations can be eliminated from your plumbing design using pipe hangers, using flexible joints, using vibration isolator and isolator springs and so on. So we talk about this a little bit. Now, in case you want to delve or go into this design or where you are designing for a building which requires good silent operation, then we have introduced two new pumps for this particular application. One is our stainless steel submersible multistage pump. You can see from here where you can actually put this pump right into the water tank itself, and that means that it saves a lot of floor space and it does not give out any noise, and you actually save a lot of pump room space. So it acts like a normal multi-stage pump, like our normal multi-stage pump, except that it is submersible, and a pump like this can achieve also very high head, especially if you're using it to transfer water from suction tank to storage tanks. So if you want to know more about this, or if you want to incorporate it into your design, send us an email and we can help you to select the pump for this.
What is the reason you want to?
And secondly, for pressure boosting systems, if you are having noise issues, or you want a pump that runs quietly, especially for a project like hospitals or high-grade offices or condominiums and so on, then you can also consider our E-Tube silent booster pump system. And you can see some examples over next few slides, but you can see from here, it acts like a normal pressure boosting system, except that the pumps are inside a stainless steel tube. So you actually do not hear any sound at all from these pumps. Very, very little sound. So over here, some example of installations that have been done. These pictures are not in Malaysia, but in other countries it's very common. These pumps are used for a lot of condominiums. So in this installation, we have 3 sets of pumps for different zones of the building. And over here, we also have sets of about 6 pumps here. And these are actually pumping pressure boosting to individual unit apartments. So actually each pump is constant pressure controlled by a variable speed drive to provide constant pressure to all the fittings. So just some examples of how silent pumps can be used. So finally, quiz number 5, and this should be now obvious. So prepare your keyboards again. So, what are 3 effective ways to ensure minimal pump noise during operation? So, I want 3 points in one answer. Okay? So, 3 effective ways to ensure that your pump will have minimal noise. Cure 1, sound barrier, pump enclosure, pipe redesign, changing power. That's a lot of points. Okay, but I'm glad you answered that. That means you have been listening very well. Okay, any others?
Okay, there's another item here, pump remote monitoring.
Again?
This one previously was in the PQ, but we don't need it.
Okay, so placement, selection, and maintenance.
CCTV.
Okay, I think we can get that. We can give that as the answer. So placement of the pumps, very important. Selection of the type of pumps and good maintenance. Okay, that will ensure that the pumps will give very low operational noise. But over here, I just put some of the points that we have mentioned. A very strong foundation that will prevent a lot of structure-borne noise, good alignment, scheduled maintenance, and the right selection of equipment. Okay, and finally, we give you a bonus quiz. Yeah. So, what happens if all else fails? And that means no matter how you design and you have installed the pump, it's still noisy. What do you do?
I think this is under YAP.
Anyone? Use Ebara. Okay. Change pump. Call my boss again. Move up. Okay. You all are thinking too much now. Pump enclosure sound barrier. Okay, that could be the cure. Fabricate a complete enclosure. But we have mentioned all that. So all that failed. That's what I'm saying. Reset again. Okay. See, the problem with your engineers is that you all overthink a problem. You know, that's the problem, engineers. You give them something simple, but they overthink and they give you a lot of answers.
Let me double check again.
This is the solution. Okay. Use earplugs. Okay, nobody got that. Okay, so it's just a joke, yeah. So, I hope with that you have actually gained something out of this whole webinar series. Oh, too late. I already showed it.
I think we submitted the latest one with the 5 liter.
Okay, so nobody got the bonus. That's a 10,000 ringgit answer actually, but it was too late. Nobody got it right. Terminate contractor. Okay, now as I mentioned, so that's the end of the webinar for today. And again, if you have any questions at all, then you can just type your questions into the chat column. And at the same time on your screen, you will see this QR code. So please take a minute to just fill in our survey by scanning this QR code with your handphone from the screen. Okay, don't use your Selanka app. This is not for Selanka. This is just use your camera. I'm sure your camera will immediately recognize the QR code. And with that, if you can just answer some of the survey questions, that will help us a lot to get your feedback. And if you are using your handphone, then just click on the link that is in the chat column itself, and it will also lead you to the survey questions. So once again, if you have any questions at all, if you want to unmute yourself, you can do so. But if you are shy, you can just type your questions on the Q&A, or sorry, the chat column on your interface, and we can take it right after this whole webinar session. Yeah. So these are our contact details. And if you need to know again any information regarding our products or require any assistance in your pumping design, just call or send us an email, either through our general email, or if you know both my email and Ms. T's email, you can just send it to us. And not only that, but if you are either from Johor, Penang, or even East Malaysia in Sabah or Sarawak, then we have our branch offices as well as our network of dealers who can help you in selecting the right pump or answer any of your technical inquiry. So with that, we want to say a big thank you to all who have participated throughout this whole webinar series. And we will continue to organize more webinars whenever time and also MCO permits. And we know that once the MCO ends, then everybody's busy, so it's quite hard to actually organize webinars. But nevertheless, if you need any more information, or whenever we have, whenever we conduct more webinars, we will keep you in the loop. So thank you, and have a pleasant afternoon. And for those who wants to stay on for the question and answer session, please just stay on, and we will flash the questions on the screen. Thank you very much.
Yeah, but then the incoming size, they didn't specify actually what is the size. What? Is it
talking about cold water or the rainwater? Talking about.
Okay, so not 7 questions anymore.
Because the drawing doesn't
okay.
show any
so we have 7 questions here, and if you do have any more questions, then you can just continue to type it there. Yeah. So let's go to question number 1. Is there any rule of thumb for the minimum height recommended for a pump room? Good question. There is no minimum, or rather there is no rule of thumb, but generally, of course, your pump room has to take into account a few considerations. One, ventilation is important. You have to ensure that your pump room is well ventilated, so space is important to ensure natural ventilation in this respect. Secondly, of course, is the facility to do maintenance. Because if you have, for example, big pumps, then you need to ensure that whenever you need to maintain the pumps, then you need either a lifting device of some kind, whether it could be a simple hoist, or it could even be a crane, like for example in a water treatment plant. So these heights have to be allowed for. And of course, a few other things, general lighting, I mentioned ventilation, but these few things. So there's no actual rule of thumb, but it all depends again on the type of pumps that you have in your, or rather the type of pumps you are using. Yeah, but I think in general, if you are in a basement, then you easily have maybe 3 to 4 meter height. That should not be a problem for small pumps. And if you are in on the roof, then if you have a project, if you have a pump house on the roof, then at least it should be minimum, 2.5 to 3 meters, just to ensure a proper ventilation and lighting for all the pump and good working space.
Correct.
So, okay, number 2, what the requirement pumps are, I think more or less we answered the same. You must have enough working space around the pump. That's important, yeah, and ventilation. So number 3, what is the recommended minimum straight length for suction pipe? Okay, technically it should be around 5 times of the suction diameter of the pipe. Of the pump. So that means that if your pump is 4 inches inlet, then it should be at least minimum 20 inches straight pipe to the pump. That will allow lesser turbulence. The longer the better, but not too long, because it creates too much friction losses. So just remember that rule, around 5 to even maybe 10 times maximum. Yeah. Okay, number 4, I have 2 questions: how to determine the spring isolation size and how to determine the inertial block size. Okay, so these are 2 very common questions. And any recommended ratio for pump inertial block. Now we talk about plinth, and when we say a concrete plinth, it should be around 5 times the weight of the pump and motor combined. But when you add an inertial block or with springs, then you basically is able to reduce the plane size. But unfortunately, the calculation for both the springs as well as the inertial block is quite technical, and there are some heavy formulas which the specialized suppliers use. So we are not the experts in this. We are not able to advise you because it is out of the scope of our pump system. But if you need more information, then we can point you to some of the suppliers that are in this field, and they can actually give you a better, let's say, a good calculation to determine. Yeah, but basically it consists of few things. Of course, the weight of the pump and motor, that affects the size of the springs, and of course also the loading points are not the same. So for your motor side may be heavier than the pump side, so the springs at the motor side may be bigger than the springs at the pump side, and so on. So that's quite technical. So best to actually talk to the specialized suppliers for this. Number 5, which one is better, flexible joint single bellow or double bellow? Okay, now single bellow is shorter, of course, than double bellows, and double bellows are a bit longer, tends to have a bit more flexibility. If you ask me, I would say that, well, it really depends. Single bellow, because of its shortness, it is a bit more rigid. It is good if your pumps are not too big, but if your pumps are very, very big, then maybe a double bellow
I think
could
we
be
have
better.
the PQ now. We have
That's
three
just
systems,
one
right? One is for
argument.
TMB SSU, one for incoming,
Secondly,
and
is
then
that
one
double
for
bellow,
distribution,
because of
correct?
more rubber element and flexibility, it may also be shorter in lifetime. So this could be a disadvantage to the bellows itself. So I'm not an expert in bellows. Again, we have specialized suppliers for this, so it's best to check with them. But I think also this
TMB
information
SSU
you
no
can
need digital,
easily
just check.
read from some of the technical journals, or even just Google it. I think you can get some answers from
Actually,
there.
the point of the TMB SSU is to charge TMB.
Okay, so I hope that basically gives you a little bit on what to look out for. So material of the sound barrier, well, there's many material available. It could be foam, it could be some specialized material. Depends on what is the treatment and how much dB that you want to reduce. It could be cheap, it could be expensive also. So again, talk to the sound or acoustic people. They are able to advise you better. If you ask me, I can only advise you from hi-fi point of view, but that's probably too expensive to talk about when it comes to pump room. Number 7, how about maintenance, BMSP? Okay, very good question. Now, the BMSP, just like any other pump, requires actually, in fact, compared to a horizontal pump, the BMSP is a submersible multistage pump. So it does not require a lot of maintenance. There's no alignment required. There's no, greasing or whatever. It is basically quite maintenance free when you put it inside the water tank. And normally, the only thing that we should look out for in the long run is let's say if there's water leakages inside or into the motor. And if your water is a clean water, then usually you should not have this issue. Normally a submersible pump, even in the borehole application, can be used for a very long time without any maintenance. So unlike a horizontal pump, it does not have to be maintained regularly or do alignment or whatsoever. It is a full single close couple kind of pump.
So for now, it's like this.
Okay. Number 8, how much the cost silent pump compared with conventional? Yes, the BMSP will be a bit more expensive, but not so much more expensive. It is what we call a mass manufactured pump, and that means that unlike a pump that is very specialized, this pump is quite commonly used. We use a lot of the same materials from our other pumps, from the stainless steel impellers, the chambers. So maybe you would expect maybe around 30 or 40% more, because the motors also are submersible motors, but not like 5 times more or something like that. Okay, but again, remember what we are saying about prevention is better than cure. So better to design right than to spend money to treat the problem later.
What do you think?
Okay, number 9. Any rule of thumb for good plumbing design? Is it 2.5D is sufficient? I'm not sure what you mean by this. You're saying 2.5 times of the diameter of the pump in what? In the suction pipe? Maybe you could put it in the chat, then we can understand it a little bit better.
For me, the impact is
the question is a bit vague, so my apologies for that. Okay, number 10, vibration still happens after alignment. What other ways to solve it? Now, if you have done the vibration, the alignment correctly, okay, and again, it depends on how the alignment was done. Now, a lot of times, if you just get, let's say, someone Okay, let me put it another way. If your alignment was done with simple ruler, and trust me, a lot of alignment are done with just a simple ruler, then it is not fully accurate. Okay, there are a few ways of doing alignment correctly. Yeah, someone from Ebara, I hope not. Okay,
So
I did not go into how are alignment done because that would be very technical, but there are a few ways to do alignment. The simplest way is to use a ruler, and then you put it at the coupling between the pump and motor, and you rotate the coupling, and you see whether it's aligned. But that is actually the most raw way of doing it. Then you have the dial gauge principle, which actually gives you a little bit more accurate. And then, of course, the most accurate is using laser. And of course, laser, just like if you send your car to be aligned in a workshop, then they have all these laser equipment. And you pay a little bit more for it. But if the alignment has been done correctly, then it should not give too much vibration. But if vibration still happens, then you may have to look for other cause. Sometimes the impeller could be out of balance. Yeah, like I mentioned, any rotating equipment has to be balanced. So if the impeller mass is out of alignment, then it creates vibration itself in the pump. So then it requires a bit more inspection. You probably have to take out the pump impeller and actually rebalance it. Yeah, just like the rims of your car. Sometimes it goes out. That's why it's called balancing. Yeah. So if you understand from the car point of view, then for the pump, you can also understand that the impeller needs to be balanced. What other ways to solve it? I think those few things that you can look at. Again, it depends on whether small or big pumps. Yeah. So get the alignment done right first. If the first alignment was done using ruler, then go with a laser, which is more accurate. And if it's still not correct, then you have to look at whether the pump itself is out of balance due to the impeller mass rotation. Does silent pump have SIRIM cert? At the moment, we are going to send it not for SIRIM, but for SPAN approval. SIRIM is usually for electrical products that are at home. If we have some pumps that have SIRIM cert for your house, our automatic pumps, but normally for this type of pumps that are used in projects, then we will send it for SPAN certificate. So we are in the process of doing that. Number 12, can silent pump use VSD? Yes, it can. So no issue. Just like any other pump, it can be operated and run using VSDs.
One more thing is the filing.
Number 13, which project in Malaysia have installed silent pump on for which services? Okay, as I mentioned, we have just introduced this pump to the market. In Malaysia right now, we have not supplied it before yet, simply because it's new. But in other countries, for example, like the installation that you saw was in Taiwan. Also in China, we have done quite a lot of installations of, using these pumps for high-rise projects. So it has been proven, and I think there should be no issue to use it in Malaysia at all. It is not some exotic pump that requires a lot of special application or the installation technique. It is quite a straightforward pump. So we should not we see that you should not have any problems with using it in Malaysia at all. Okay, number 14. Is it necessary to provide harmonic filter for all VSD pumps? If not, when to introduce a harmonic filter? Now, most VSDs, I would not say most. I think in general, some brands of VSD have a low-level harmonic filter built in, and that basically solve the problem of harmonic
Are you doing
currents
the
that
side, or you want me to
that generates from the
on my
VSD.
routines
In our case also, our VSDs have the harmonic filters. That is why you do not hear this high pitch noise in our Ebara Pump variable speed drive. But you may have come across older installations, VSDs of different brands. I wouldn't say who, but we have come across this type of VSDs where there's a high pitch noise created. So to introduce harmonic filter, yes, it can be introduced in the line. Harmonic filters are quite expensive. The bigger the kilowatt, the more expensive it is. But I would say best to talk to the VSD supplier because they would know where the problem is.
Utility mapping inside our
and whether using harmonic filter is the best solution for it.
We have done our own
Number 15, can the silent pump function as a self-priming pump? No, it is not a self-priming pump. It is basically, we talk about two pumps there. One is the BMSP. It is actually a submersible pump. But the E-tube is basically a submersible pump in a tube. So to answer your question straightly, it is not a self-priming pump. It needs to be filled with water in order for it to run.
But I do not want
Number 16, in case of maintenance and service, does the water tank have to be drained off or lift out the BMSP pump? Very good question. So, no, you do not have to drain off the water tank. You just need to lift up the BMSP pump because, let me just show you the pump picture again. Oh, sorry. Yeah, okay. No, anyway, if you remember how the BMSP pump looks like, okay, maybe you can share.
With the congested, with many underground services, we will do piloting.
Okay, let me just share back my slides.
So I don't think
the method of statement is very important. Okay, now
there's a bit of lag here.
It's okay if you think you don't need to do the utility mapping. You are fine.
Okay, here you go.
Because we already done
So
all these things. We also do not want subcontractor to waste this money.
Okay, there's a bit of lag here, so you're not seeing all the slides yet. Okay, so here you go. So you have this
before you proceed for any
BMSP pump.
Okay, because as you know that this is
where
this is not
if you can see from here,
it's a site that used to be a college before.
The pump is basically a cylindrical pump where the suction of the pump is below, and you can see here it's like a steel or mesh, and the water actually goes in here, and from there the pump elements are on top. So basically the motors are actually inside this area. So it basically the water goes in, it cools the motor, but at the same time it's pumped up by the impellers and the chamber here. So I don't know why the drawing is not showing. It's a bit of lag actually.
We do not cater for time being, okay? That I think is
today's internet is not so good.
Instead of putting a lot of assumption and
okay.
This and that. So if let's say it really happens, only we will see.
Maybe let me share the actual drawing.
Tackle the problem.
I think we can base on this basis to work out something. Okay, so but based on the CK, if can we provide them the utility mapping that we have as their reference. So subcontractor, you have to do your part to double check to make sure that whatever the manhole or the pipes are actually in this design is actually is already counter protect about the work. So please, you have to do your part to double check. Okay.
Yeah.
Okay. I will send you the file. My only big concern is on the manhole where
the manhole so I hope you can see it in your screen now. So this is how installation of a BMSP can look like. and basically the pumps will be inside the water tank, and the discharge pipe is connected to the top or the top outlet, and you just need to, usually you have one duty, one standby. So with that, you can put your isolating valves and check valves on top, and then you just straight out. So if you need to maintain the pump, then you just need to remove this part, and then you can pull the pump out with the pipe. Okay, the pump is not very heavy, so it's quite straightforward actually. So you just ensure that you need to create an access on the water tank to allow for the pumps to be installed and to be taken out.
Just be clear, it's 12 months, not 24.
Okay, so I hope that answers your question. Of course, the two pumps will then be connected to your standard control panel for starting and stopping the pumps and for automatic control.
There is a digital water meter, so you need to price for that. I think in the BQ that you had before this, there wasn't an item for this, so you did not price.
Can you share back the...
But the signal and power cable from control panel.
Yeah, basically your signal and power cable is from your own control panel. The power, but
we don't have.
Okay, so number 17 for question 10. Impeller change new already.
So how many?
Okay, we really have to see. I'm not sure who actually or what was done. We need to study,
we don't have any separate
or rather go to the site. But if you say that the alignment has been done, and impeller has been changed and it's still vibrating, then probably you need to really look into what is causing it. I believe the alignment may not have been done properly or very well. So try to do it again. Maybe the first time it wasn't done right. Alignment is what we call you need experienced technician to do it. Not anyone can do it. So if the alignment wasn't done properly, then you would also still get the same effect. But I mean, I cannot answer this question immediately as a solution. We need to actually see where the problem is. Okay. Yeah, number 19, if there's not enough headroom, can't remove the pipe and pump. Agreed. So you probably have to allow for that, or you may have to make your pipe in a few sections. That could be one way, just to counter the effect of low headroom. So have the pipe in, let's say, 2 or 3 sections to the tank, and you can just dismantle section by section. Number 18. Okay, how silent is a silent pump? Now, it's as silent as silent. So in short, if you put it inside the water tank, you will not be able to hear it at all, because and your water tank, I presume, will be quite big. So you will not hear it because it is inside the tank. Yeah, you will only hear what is around the water tank level.
I only provide the meter.
We say it's below 40 dB simply because even if you put an audio meter where you are sitting right now, I believe you would already get about 50 to 60 dB, unless you are in your house, it's very quiet. But I just measured my environment in the office, and it's already almost 60 to 70 dB. Okay, so I believe that's all the questions that we have today, and I hope that once again this webinar has been not only interesting but beneficial to all of you all. So with that, I want to just thank you once again from all of us in Ebara who have for you all who have participated in all our 3 webinars, and we hope to again see you all the next round when we have another webinar session. So keep the questions coming, send us an email, and for those who won the quiz, if you have sent your details to us, then we will arrange to send out the gift for you. Okay, thank you very much, and have a good weekend ahead. and see you again. Bye for now.
What BMS, what Siemens do now, there's interfacing panel, there's a junction box. There's junction box somewhere around near the pump or whatever. Then all supposed to run to this interfacing panel, right? Not just pump, there's a lot of monitoring things there. Not just pump, there's a lot of monitoring things there. It is a few one. Mm. Mm.
No. Yes,
Mm.
yes.
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 Yes. Yes. If let's say they need it up, but for
Actually, I can find.